Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartyurl.it/Jedi. My advice on how to pass actuarial exams is at smartyurl.it/pass. This video channel is at smartyurl.it/pass actuarial exams. Here's information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smartyurl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smartyurl.it/help-ISU-actuary. Here's the problem for today for exam LTAM. You are given the following data based on 60 observations, and you have the times of departures, number of people, you can take them as dying, and BI, a number of people who are leaving for other reasons. Calculate the upper limit of the 80% confidence interval for S of 21 using the Kaplan-Meier estimate and Greenwood approximation. Now, the important thing to note here is that this is not clearly stated, but it's implied that this is 80% symmetric confidence interval with the center at the estimate of the mean and plus minus to the top and the minus to the bottom. So there's an upper limit, there is a lower limit, and so that means that there's 10% above the upper limit and 10% below the upper limit. So the Kaplan-Meier estimate of S of 21, the last value of yi, is and it's a product of these expressions, which are basically the same, 1 minus S1 over R1 times 1 minus S2 over R1 minus S1 minus B1. It's the same from this point on until the end. So S3 over R2 minus S2 minus B2, and then S4 over R3 minus S3 minus B3, and then 1 minus S5 over R4 minus S4 minus B4. And we plug in the numbers for all of those, and we calculate, and we get approximately 0.18333, going on forever. 3 goes on forever in this. The variance of the Kaplan-Meier estimator is given by the Greenwood's approximation, and the Greenwood's approximation formula is provided in the table for exam LTAM. You can find that table at smartyurl.it/SULT. SULT stands for Standard Ultimate Life Table. And this is equal to Sn of y squared times the sum over I such that yi is less than or equal to y of Si divided by Ri times Ri minus Si. So in this case, this becomes S of 21 estimate squared times 5 over 60 times 55 plus 6 over 48 times 42 plus 7 over 35 times 28 plus 6 over 21 times 15 plus 6 over 10 times 4, and it's approximately 0.00607292. And then the upper 80% confidence limit is calculated using the 90th percentile of the standard normal distribution, and we're using the 90th percentile because the numbers above the 90th percentile constitute 10% of the probability distribution. And the symmetric confidence interval has 10% above and 10% below the lower limit, so the upper limit corresponds to the 90th percentile of the probability distribution. And that's equal to 0.18333 plus the 90th percentile of a standard normal distribution, which is 1.282, times the square root of 0.00607292, and it's approximately equal to 0.283821, and that's answer B. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies, and good luck on the test.